Okay, so Mr. True again. Now that we've talked about some of the quantitative graphs, you might want to read about something called a dot plot. We've covered stem plots and histograms. We want to discuss or talk about how do we describe these distributions. So the four things you want to remember when describing a distribution is shape, center, spread, and outliers. Now, very, very important to be able to describe a distribution well. Use numbers, use your data, make sure you mention all four of these variables. The first question of every AP stats test I've seen so far, they release the questions, you can look them up on apcentral.collegeboard.com, is the very first question is always about data, well, describing graphical situations like this, shape, center, spread, and outlier. So shape, is it symmetric or left skewed or right skewed? Is there a big gap in the middle so it's bimodal? Or is there only one peak? Is it unimodal? Center, well, you have three choices, mean, median, and mode. Mean is when you add up all the numbers and divide by, whatever. If you got 100 numbers, you add them up and divide by 100. The median is when you take your numbers, you list them from low to high, and you just go tick, 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 till you get to the middle one value or the middle two values. And then if you have the middle two values, you average those up. Or, if you're going to describe a distribution, the easiest measure of center to identify is the mode. We'll be doing that in a minute. So, for measures of center, you have three versions, or three choices, mean, median, or mode. And for a visual, like if you want to just look at a graph and describe what you see, the mode is the easiest measure of center to talk about. You got spread, well there's something called a range, which is probably the most common measure of spread, is just take the max value, or that'd be to your right, the max value and the min value and subtract them. And remember that the range is only one single value. So here we have a graph displaying a min of around 20, a max of around 100. Well, then that would give you the range of 80. You don't ever say the range is between 20 and 100. You can say the min is 20 and the max is 100. But your range is that one value, that one difference, which is 80. Well, at least will be in this example. IQR, you just write this down. There's a lot to talk about in statistics in the beginning, and I'm not sure if I want to get to Q3 and Q1 type stuff in this little video, but there is another measure of center called IQR, and that's the spread of the middle 50% of the data. For now, you might want to just write that down because you don't really understand how to find the quartiles yet. And then finally, your outliers. So here we have a histogram that displays, again, some grades. I'm just going back to that old, value, that old example I keep doing in these videos so far. And we have a few kids doing poorly, a lot of kids getting in the B range, or the 80s, and then 90 and 100. 90s and the 100s would be, your A's. Okay, why is this a histogram to begin with? Why is this not a bar graph? Because I'm letting my numerical values represent a continuous random variable. I'm not using the scores to group them into letter grades like A, B, C, D, and F. Keeping them as the raw score. So, histogram. I have my values in the middle here. Again, if you haven't watched the other video, you can also have this displayed as 20 to 30 to 40 to 50. Now, a common mistake I see students make, especially if they're pulling numbers out of their textbook using a table, like 20 to 30, 1 kid, 30 to 40, 0 kids, 40 to 50, 4 kids, where they make this x-axis look like this, 20 to 30, 30 to 40, like they're attempting to label the x-axis, but really what they're using is the table labeling to put into the graph, and this is not correct. If you're going to put numbers on each of these tick marks, just do it once. 20 to 30 to 40, 50, 60, 70, 80, 90, 100. And for that one kid that scored maybe a perfect 100, I got to go to 110 because, again, this last interval represents x's that are greater than or equal to 100 and less than 110. So this interval is for x's that are greater than or equal to 90 and less than 100. So if that one kid that scored a perfect 100, you'd actually have to make a new class interval for them and put it over here. Okay, so how would you describe this distribution that is skewed to the left? See, I haven't even talked about that with you guys yet. So if you have a peak on the right-hand side of your graph and it tapers down to the left, that's called a left skewed distribution. And I'm going to really break this down for you quite heavily and talk about how these three measures of center would show a left skewed distribution. If it's right skewed, it's all the opposite. I'll highlight that before this 15-minute period is up. Okay, now I don't have time to write this, but please, pause it, replay it, and write it down, or read your textbook for examples on how to describe a distribution. This is a left skewed distribution, the pointy side is the left. This is a left skewed distribution shape with a min in the 20s and a max in the hundreds, giving me a range of about, let's say, 80. I just talked about spread, shape and spread. Most scores were in the 80s. Oh, so I just talked about center, that was a mode. And there appears to be no apparent outliers. There's a gap in this class interval here. No one scored between 30 and 40, but the grades slowly tape down to the left, so I would not call this area an outlier. So this is a left skew distribution with a min of around 20 in the 20s and a max of about 100, given a range of 80. The most common score is in the 80s, and there's no apparent outliers. In those very short, simple sentences, I talked about the four things you need to discuss when you look at a distribution: shape, center, spread, and outliers. Here we have a left skew distribution. Now, I have not talked about these concepts yet, but you can hear them and we'll discuss them later as we continue to go through the notes. When you have a left skew distribution, and we're talking about these three measures of center. When you have a left skew distribution, the mean is always closest to the tail. Now, I'm not really sure where the mean is in this data, but I do know it's going to be towards the left side because that's where the tail tapers off. Probably not quite this far. So don't think I'm saying it's 50. I really don't know what it is. When you have a left skew distribution, a little bit larger than the mean is the median. Okay? And I just eyeballed that. I have no idea where the median is. We'll actually maybe stop and erase this and recalculate where the median is in a minute. And the mode is always where you have the peak of your graphs. The mode is in the 80s. So when you have a left skew distribution, the mean is smaller than the median, and the median is smaller than the mode in numerical value. If it is a right skew distribution, we'll put this here. If it's a right skew distribution, then the mode is the smallest measure of center. The median is a little bit larger, and then the mean always being closest to the tail is going to be larger. So if you have a right skew distribution, right skewed, since I'm kind of running out of room to write, you have your three measures of center. When it's a right skew distribution, the mode is the smallest measure of center, then comes the median, and then always closest to the tail is the mean. I jump around a lot when I talk about AP stats in the beginning because there's so little that you do know that I kind of jump around a little bit, but you'll see this in notes later on as well. So if you don't have it written now, you'll have it written if you keep watching my videos as we go through the first, as we go through the year. If you have a symmetric distribution, whether it's a bell curve like this, or whether it is, even if it was bimodal, such as this. Some of this might not make sense unless you read your textbook. But if you have a symmetric distribution, your mean and your median will be roughly equal. So if your mean and median are roughly equal, that's your sign of symmetry. If your mean, your median, and your mode are equal, well, and this will be repeated later, I'm kind of jumping ahead a little bit, but if your mean, median, and mode are all the same, that is a sign that you have a unimodal symmetric distribution. Let's see here. Let's try and figure out really where the median actually is in this histogram. Well, I've got one number, two numbers. I got two people in this category, so that's 1, 2, another 2 make 4. Another 2 people is 6. Another 3 people is 9. Let's call that 4, so 13, 15, and 16. So this graph represents, the way it's made, as a frequency histogram, represents 16 pieces of data. So if the median goes from low to high, then the median should be the middle number. Okay, so if there's 16 pieces of data, that means there's 8 over here in the low end and 8 over here in the upper end. So I want to find out, like, where is about the 8th, 9th number to estimate the median from this histogram that I've now scribbled all over. Okay, 8th number, right? Low to high, counted the tops up, got 16 pieces of data. So I want the 8th number or 9th number. 1, 2, 4. Okay, so I guess I was wrong. 6, because I'm not to the 8th number yet. So actually, if I want to do this extremely correctly, or roughly, then this comes out and 1, 2, 4, 6, and another 3 make 9. So the median is actually, if you want to go back and change your notes if you already wrote that, somewhere between 70 and 80. So, left skew distribution. Mean is the smallest measure of center, median, and then mode. If you have a right skew distribution, then it's just the opposite. And by the way, this will come up in your textbook as well. All money questions are right skewed. You know, you always have a lot of people down doing the grunt work, and then the few people at the top of the company making, you know, the big decisions, and the CEOs of the companies, the stars of the football team or whatever. You always got that handful of people making a ton of money. All money questions in our textbook is going to be right skew distribution. So, that's a quick introduction on how to describe the shape of a distribution. Don't forget, shape, center, spread, and outliers. Don't forget to read your book, read the examples, and do the homework, because you're going to want to have these class discussions and get help from your teacher, because they will get a little bit tricky. So there you go. Bam!